So here are some observation results. So this one is from a cruise, the Greenland Sea, March, April 1994. And the aim of this course was to determine the degree of dense water formation in the Greenland Sea. Okay, and luckily I was part of that cruise. That's when I did my diploma. And here's a picture of the vessel. This is the Valdivia, was owned by the University of Hamburg. Once we went to the Greenland Sea, and here are some observations. Here on the left side, you can see at the beginning of the cruise from the central Greenland Sea, essentially density. It's the density structure here expressed in terms of something like a sigma T. You can see a surface mixed layer 300 meters deep, and then the density increases. So at the end of the cruise, 25 days later, we did more observations using CTD stations. And you can see that the depth of the surface mix layer has increased to about 600 meters. And this is the result of convection in the ocean. Convection mixes. However, convection was not very deep during these years, and later on we learned that the deep convection was actually taking place in the Labrador Sea and not in the Greenland Sea. Okay, there was a big competition between two institutions, one in Kiel, one in Hamburg, and Hamburg decided to study the Greenland Sea, and the guys from Kiel were more successful, more lucky with finding very, very deep convection of several thousand meters in the Labrador. Anyway, but what we did we did something very special. So it's shown here on the next slide. There was a guy on the cruise, Jürgen Selschop, who built do-it-yourself a so-called thermistor chain. Okay, it's a chain, a vertical chain of temperature sensors. Every 5 meters, a temperature sensor, and the total length of 500 meters. Shows you a little bit the structure of that. Okay, and it took him several years to build. Okay, so what you essentially do is you have it on a big winch, and then you lower the temperature sensor into the water column, and you measure the temperature structure, and then while the ship is cruising along. This image behind me here shows you the observations. Okay, the pressure, the vertical axis, is essentially proportional to the water depth. Okay, you have something like 400 meter water depth here, and you can see the fine structure of convection cells in the water column. You can see the dark blue is colder, okay, and the lighter blue is warmer a little bit. I mean, it's very cold water here, but just a little bit warmer. And there's some color reversals here. So this is essentially the base of the so-called halocline, the base of the mixed layer. Okay, it's a lower salinity surface layer, which is very cool. And this one, this actually shows the structure of the convection. Okay. And the scale of these convection or convective plumes is sort of 1-to-1. You compare the horizontal to the vertical scale, it's called an aspect ratio is about. However, there was a storm coming in, big storm coming in, and we were sort of keen, the chief scientists were keen to keep this measurement going as long as possible. And the captain said, no more people are allowed on the deck because the storm came a little bit earlier. So there was no way to get that thermistor chain back on deck. The storm came. It was a massive storm, and it actually broke this chain, and the chain disappeared into the deep sea. And it took 2 years to build, and they invested more than $1 million into the development of that. And that's now buried forever on the bottom of the Greenland Sea. I can tell you where it is, okay, but it will be very, very tricky to get it back. It's just one of these stories, all right? But it's a true story.